Hey guys, today we're going to be looking at P.2, which is about integral exponents. So the first thing to remember is that a to the n, so n is just some integer, it's just a times a times a times a n times, and then we also have this definition that says a to the negative 1 is 1 over a, and if we also do 1 over a to the negative 1, we get a. And from these two definitions, we get these 5 properties down here. If we multiply with the same base, so here a is the base, and we have m is this exponent, and then the n is this exponent, then we just add the exponents. Division changes to subtraction. Right. And now we also have these extra 3. If you take a, raise it to the m, and then raise that whole thing to the n, well, that's writing a m times, and then doing that n times, which gives you a mn times. And then with multiplication and division, if you take two things being multiplied or divided, then you can distribute this m exponent in. So a times b all raised to the m is the same as a to the m, b to the m, and a over b raised to the m is a over m over b over m. So first note that there's no addition rule, so this rule isn't true. We're talking about the right. Alright, so if you have a plus b all to the m, that's not the same as a to the m plus b to the m. This rule doesn't apply to addition and subtraction. Just make sure you only use this distributing the exponent when you have multiplication and division. Alright, so now let's look at these two examples where our only goal is to use our rules here on the left and try to simplify both of these expressions. So the first one, what we're going to try to do is separate this into where we're only looking at the same base at the same time. So instead of thinking about a lot of multiplication in the numerator and a lot in the denominator, I'm going to rewrite this as, well, I can separate this into negative 6 over 2 times a to the 5th over a to the 7th times b to the negative 1 over b to the negative 3. So these two things are exactly equal. I just separated over each of these multiplications. So if I multiply all these numerators and multiply all these denominators, I get back to what I started with. Now we just want to use these rules over here to simplify this. Well, negative 6 over 2, those are just real numbers, so we know that's going to be negative 3. And now here we have a to the 5th over a to the 7th. So we're going to use our second rule here that says if we have division, we're just going to subtract the exponents. So this is times a to the 5 minus 7. And here, again, division is going to be subtraction, so we have b to the negative 1 minus negative 3. And again, use your parentheses. So we're going to use a parentheses around this negative 3 because subtracting negative 3. We don't want to miss any minus signs. Alright, now again, we're just going to do these subtractions. So we still have this negative 3 times a, and now 5 minus 7 is negative 2. And then negative 1 minus negative 3 is the same thing as negative 1 plus 3, so we get b squared. Alright, and now the instructions in the book say to write this with only positive exponents. So the only thing we have now is this negative exponent in the a, but this rule to the left here says we have a negative exponent, then we just put it in the denominator. So this is the same as negative 3b squared over a squared. So now we have all positive exponents exactly like we wanted, and this expression here is the same as the expression at the top, just much more simple. So we're going to do the same idea for b, except for now we have variables in the exponents, and we also have the whole thing raised to another exponent. So the first thing we're going to do is move this exponent into each one of these, because we can use, all we have is multiplication and division. There's no addition or subtraction, except for in the exponent, but we're not worried about that right now. Alright, so there's no addition or subtraction, so we can distribute this exponent into here. So it's going to move into all 4 of these exponents. It's going to move into the exponent of the 3, move into the exponent of the a, into the 2, and again into the a there. Alright, so what's that going to look like? Well, now we have 3 with this new exponent, a. The exponent, this a, is being raised to another exponent, so we're going to get multiplication. That's what our rule here says. So we're going to have 3 times 2m minus 1 over, and again this 3 goes down here, so now I have 2 squared, and then a, again this 3 is being multiplied by the exponent that we already had, and now we have this expression. And I'm going to do the same thing I did over here where I split based on the base. So this 3 cubed is 27, and this 2 squared is 4. So I'm going to move those outside here just like I did this negative 6 and this 2. All right, that's multiplied. And I'm also going to distribute this 3 into here. So I have A. This 3 distributes in here, so 3 times 2m is 6m, and 3 times negative 1 is negative 3. And that's all over, well, this is just multiplication, so we get negative 9m. We can't simplify 27 over 4 at all, so we'll leave that. Alright, but what we can simplify, here we have the same base, they're both base A. We have 2 different exponents, so we know that's going to simplify down into the top exponent, the exponent in the numerator, minus the exponent in the denominator. Again, be careful with parentheses, so we have minus the entire thing in the denominator, which has a negative with it. Alright, so now we're just going to simplify this as 27 over 4 times, these are supposed to be cubed, this is supposed to be cubed, so this was an 8. Alright, so I fixed that now. These are all 8s. Alright, but now we're going to see what this becomes. We have 6m minus 3, and now this negative becomes a plus 9m. And our final answer, this 27 over 8, again, we can't simplify, but we have this A, 6m plus 9m, it's going to get us 15m minus 3. Alright, so this expression down here is the same as this top expression here, but it's just simplified down. Alright, so these rules to the left are the only rules you should use to simplify exponentials. Again, don't use the a plus b to the m. That's not actually a rule you can use. So only make sure you're using these bottom 2 rules between multiplication and division, and not addition and subtraction.